Hey folks, welcome back for another episode of Code Club. If you have been following along in the last couple of episodes that I've been posting, you know that I have been recreating plots that were created by W.E.B. DuBois, who was an African-American sociologist who was at Atlanta University at the time. I think he finished his career at UMass Amherst, which is where I happened to start my career 15 or 16 years ago. Anyway, he went to the 1900 Paris Exposition to show the French and Europeans the status of blacks in Georgia as well as in the United States as well. He made a series of very compelling and very attractive and, dare I say, very interesting looking plots. And a lot of these plots are not what we typically see or make using our modern tools like ggplot2 or Excel or Prism or Tableau or any of those tools, right? And so I'm taking this as a great opportunity to try to recreate these classic visualizations using ggplot2. I'm trying not to use any other R packages, but merely using R, ggplot2, and other tools that come with the tidyverse, as well as a package called showtext that allow us to incorporate fonts. So here is the plot that we are going to make today. If you look at this, right off the bat, I hope you think pie chart. That is a pie chart. That looks a lot like a pie chart. And it is, right? And so I think I've heard people refer to it as a fan chart because it's got two parts to it, if you will. So on the top is representing the data for blacks in Georgia, and on the bottom, whites in Georgia, indicating what occupations they had. And so for both races, about 2/3 were in agriculture, right? And then for blacks, domestic and personal service was about 1/4, followed by manufacturing, and then trade and transportation. I'm not really sure what that means, except perhaps something related to moving materials around. And then the professions. Whereas for whites, again, 2/3 in agriculture. Georgia, for those of you who don't know, is in the southeast corner of the US and has been known for a great agricultural state. And then about 5% or so in domestic and personal service, and then 13.5% for manufacturing, 13% for trade and transportation, and 4% for the professions. So I got this image from the U.S. Library of Congress, which has all of the panels that DuBois and his colleagues from Atlanta University showed at the 1900 Paris Exposition. This was panel number 27. You can get the full collection in this book, W.E.B. DuBois Data Portraits, Visualizing Black America. And I think it's a really compelling read. All the panels that he presented are in here, along with some other background information. I'll also put a link to a video up here that I watched recently that was put up by the company Tableau that I thought was really good in talking about these data visualizations. So there's a couple things that stand out to me about this that are going to be interesting to try to implement. So the first thing that catches our eye, at least my eye, is that the wedges are taken out of the right and left side of the circle. It's kind of like a Pac-Man on both sides, right? And that the same categories are on the top as in the bottom in kind of the same but kind of opposite order. So we'll have to do something with factors there. The second thing that's interesting to me is that the legend is mapped on top of the chart rather than off to the side, with agriculture and manufacturing on one side and the 3 other categories on the other side. Something else that I noticed that is subtle is that the placement of the percentages is not at the same radius all the way around the circle, right? Also, if you look closely, you'll notice that the font sizes are different in some of these wedges. And so because of that, kind of the typical way you might make a pie chart in ggplot2 won't work. Trust me, I have tried. The typical way that you would make a pie chart is to make a stacked bar chart and then use chord radial to convert it from Cartesian coordinates to radial or polar coordinates. Trust me, I have tried to get this to work, but it is just a royal pain in the neck. Finally, I noticed a comment posted to Stack Overflow by someone who I really respect named Klaus Wilke at the University of Texas. He's done a lot of great stuff with ggplot2. Somebody was asking questions about how to manipulate text on a pie chart. And he said, please stop, do it manually. And so that's what we're going to do. Instead of using chord radial, we're going to make this entirely in Cartesian coordinates. This is going to force us to remember our trigonometry skills. But don't worry, it won't be too bad. I will walk you through it as we go about generating our code here in RStudio. If you want to get any of the code that I am generating today, you will find down below in the description a link to a blog post for this episode where I will present all of the code. There's two things that you will need to install that I've described in a previous episode, which is the B52 and the Vasserly font. And we incorporate these using the show text package. These are two fonts that come pretty close to representing the fonts that DuBois and his colleagues used. So let's go ahead and load the tidyverse, show text, and our fonts. And so now we have everything loaded. I have also gone ahead and made a tibble that contains the 5 different categories, as well as the percentages for blacks and the percentages for whites. Back in 1900, Black people, Black Americans, African Americans were called Negroes. That is not a term that we use any longer, but I am using it where DuBois used it. Again, today we typically refer to these individuals as Black people, Black Americans, Black Georgians, or African Americans. So that is the practice that I will do my best to follow. So again, we have this table of the 5 different categories and the 2 different races. When we think about making a plot, we want to make it tidy so that each column represents a distinct type of data, right? And so when we think about this fan plot, we're going to have kind of 3 different aesthetics, right? So the first obviously is the color. So each of these different categories is going to get its own color. We will also be adding race to this because we're going to have a top and a bottom. So we'll have to think about that. And then the percentage. And so that on like a Cartesian coordinate system, like a typical line plot, the x-axis might be time and the y might be a percentage or some weight or something like that, right? And so I need to get this tidy so that I can have we already have the category. We need the race in a column. We need the percentage for each category and each race. Something that we're not going to need immediately is the position or the radius, right? And so I'm going to work with a circle that I'll assume has a radius of 1, okay? So let's go ahead and make this tidy. So we'll do pivot longer, and we'll do minus category, and we'll do names 2, and I'll say race, and I'll say values 2 equals percentage. And so now you can see we've got the category, the race, and the percentage. Refreshing ourselves of the plot that the data for blacks is on the top and for whites is on the bottom. And so we're going to need to kind of put those together, right? Because if I were to make a pie chart of this, well, let's go ahead and do that just so I can show you what it would look like. We could go ahead and pipe this to ggplot2, and on the x-axis, we'll put double quotes because it's an unnamed category. And on the y, we'll put percentage. Our fill would be the category. And then our group, I'm going to say paste, category, and race. Then we need to do geom call to make the stacked bar chart. So here is our stacked bar chart. And I'm noticing that it has pooled together the 2 different races. And so maybe what we need to do is repeat this paste for both these. So now we see that we have 10 different categories, right? But that it's alphabetizing, right? So the agriculture goes at the top, followed by manufacturing, profession, services, trade, right? And so we want to order it by race and then by category, right? And so we could, of course, flip this to do race, comma, category. So let's go ahead and do that to see what that would look like. And so now we see that we have the blacks at the top here, and then the whites at the bottom. And so then if we look at the order here, that we go from agriculture, but here we do then domestic services, right? So services would go next, but this is an alphabetical order, not the order of the chart, right? So we'll need to use a factor to reorient that, but we'll get there in a second. So let's go ahead and then convert this to a pie chart. And then we can do chord radial. This then shows it as a donut plot. And I think that is because we want theta to be y. And I think the y needs to be in quotes. And so now we get our pie chart. But as we've seen in the past, ggplot likes to add and expand. So we could do expand equals false. And so now we get our pie chart, right? And so we could go from here and clean things up. But as I've mentioned, I have tried that and it is a fool's errand. So we're not going to do that. But what this did show us, though, is that we need to get our categories into the proper order using a factor. And so let's go ahead and remove this ggplot stuff. And again, at this point, we've pivoted it longer. And so we have the category, the race, and the percentage. Let's go ahead and make a new column. So we'll do mutate. And I will do race category. And we will then do paste. And we will then do race category. And then I'll do sep equals an underscore. And so now you'll see that we have race category where we've got the race underscore and then the category, right? But we need to modify that to be a factor. And so we'll take race category again, and then we'll do factor. And then we'll do factor on race category. And then we'll do levels. And then we're going to put the levels in the order that we want them in, okay? And so this might take some futzing once we finally start making our plot. So I'm going to go ahead and fill this in the order that I think is right. All right, so I've gone ahead and populated the levels to set the order. So now if we go ahead and run that, get our data back, and we now see that race category is a factor. It's not in the correct order, so let's go ahead and do an arrange. And we'll then do race category. So now we see that the race categories are alphabetized. And what I'm noticing is that it's kind of in the reverse order of the percentage for the blacks, right? And so very few professions, but far more in agriculture. I suspect that was intentional. And then they use the same order for the whites. Okay, cool. All right. So now, again, we want to think about how we're going to plot this data. What we're going to do is we are going to effectively draw the individual wedges. So we're going to need to generate the data for each wedge of the pie chart and then put it together. The way we can draw a wedge is using what's called geom-polygon. So let's do some experimenting here, okay? So let's go ahead and say that we have an initial theta degree, right, of say 30 and a final of say 45, okay? So that's degrees. R is going to want things to be in radians. And so we're going to need to convert this by dividing by 360 and multiplying by 2 pi. So we'll do 2 pi divided by 360. And we'll go ahead and add spaces there. And I'll go ahead then and copy this down. And so then our initial and final values are those, right? And so now we need to make a range of theta values, right? And so we can do that with seek. So we can do seek initial, final, and then we can do length out. And let's do 100. So basically we're going to have 100 values between 0.52 and 0.79. And I forgot a G. All right. So there we go. We've got those 100 values, right? And let's say that our radius is 1. So these are going to be our thetas. And let's go ahead and put our radius and our thetas together. And then what we're going to want to do is we're going to want to convert that edge, right, between like 30 and 45. We're going to want to make that into a line. And so we can convert radius and thetas to x and y. X is going to be the radius times the cosine of thetas, right? And then the y, maybe this is coming back to you, will be radius times the sine of the thetas. And so let's go ahead and I guess we don't need to assign this to a variable, but let's say x equals that and y equals that, and we'll put this in a tibble. And let's go ahead and clean this up, and I forgot an E up here. All right, so this is our tibble, right? And so now what we could do is we could go ahead and do ggplot AES, x equals x, y equals y, plus geom line. And so you can kind of see a curvature here, right? We do chord Cartesian, xlim equals -1 to 1. And of course, this needs to be in a vector. And so we'll go ahead and do that. And then I'll copy this and make that ylim. Okay. So now we can see that it's a bit of an arc there, right? But we want the wedge. We want it to come down into 0. What we can do is trace the path of the wedge. And so I'm going to make this a vector. And so the x is going to start at 0 and then go up to the edge of the circle, around the portion, and then back to 0. We can again do 0 here. And so we'll do the same thing for y. So we'll do C0, comma, radius sine thetas, comma, 0. And now instead of geom line, what we're going to want is geom polygon. And so there is our polygon, right? We now have our wedge. You might notice a little bit of distortion, and that's because the aspect ratio is slightly off, right? Like, so from the width of the plotting window is shorter than the height. So if we want those to be equal, we could go ahead and do chord equal. And so now that is a much better proportioned wedge, right? And so this is the strategy that we can use to make a wedge for any initial theta to final theta. So let's go ahead and make this, okay? So we're going to make a function that I'll call generate wedge, and that is going to be a function that'll take a theta initial, so theta underscore I, theta underscore f, a radius. By default, I'm going to make it 1, and then I'll make a resolution argument that I'll say is 100. We might want that to be 1,000 or 10,000, but let's start with 100, and we'll assume that that's a pretty good default. And then we'll define the body of the function. And so let's go ahead and grab this, and we'll plop it into the body of our function. And so we'll have to update some things, right? So our thetas will go from theta I to theta f. Our length out will be resolution, right? And then we have our radius, and then we have our thetas going in here, right? And so I think that's everything we need. So let's then go ahead and do generate wedge, and we'll do initial, final. We need to make sure we've got all this stuff loaded. I think I've forgotten to do that. And so there again is our wedge. That worked. So if we want to prove to ourselves that that worked, we could go ahead and change some values. Let's go from 90 to 115. And so now our wedge has moved, right? Hopefully you can see what we're doing here, that we can create an initial theta to a final theta and then draw any wedge. We're not going to draw wedges individually. Instead, I'm going to make a data frame building upon this tibble, right? Where we will know the initial part, right? Because we're going to look at the percentage of kind of the whole, right? And so the Negroes column and the whites column both add up to 100. And so we could divide everything by 200 to get the proportion of the circle that should go for each of those wedges. Does that make sense? So we need to get the initial theta and the final theta for each of these. So to remind ourselves what this all looked like, we can have our percentages, right? What we'll do is we'll go ahead and we'll create another column that we'll call mutate, and we'll do theta, and then we'll do 2 times pi times percent divided by the sum of percent, okay? And so basically percent divided by some percent is going to get the fraction of the 100%, the full circle that goes to that race category. And then we're going to multiply it by 2 pi to get the angle in radians. Oh, and it's upset with me. Why are you upset with me? And I think I put percent instead of percentage. All right. I'm going to go ahead and change this to percent because I'm lazy and those 3 extra letters are just too much. All right. So this is the theta for the upper edge, if you will. Basically right between this brown and gray wedge, right? But this is not 0, right? This axis is not 0. It's up about 30 degrees, right? And so we need to add a dummy variable. So I'm going to add a blank category that is 30 degrees, okay? And so let's go ahead and in here, I'm going to create a new category that I will call blank. So for the Negroes, I'll go ahead and I'll put 60. And then for whites, I'll put 60. And that won't be exactly 30 degrees, right? Because that's going to be 120 out of 320, right? But I think it'll be close enough. So then we need to add a category for blank. So that is going to go at the beginning here. I'll put in the Negroes blank. And then we also need the whites blank at the beginning of that group of factors, right? So we'll go ahead and replace this with whites. So I'm going to go ahead and quickly clean up the indenting here. I see that I've got a NA down here, and so I somehow lost the whites. All right, so now we've got all our categories, and that looks great. And so now we see that Negroes blank starts at 1.18. So that's good. We might have to adjust this later because I'm afraid that that's going to start at 0 and go up to 1.18. So anyway, but we'll deal with that in a bit. So again, this theta is going to be for the upper edge of each of the wedges. And so we need to add to those values to get kind of the upper edge for each successive one, right? Because if we look at our tibble here, the theta is 1.18. So if we make that the final theta, then we're never going to get past 1.18 or 1.22 radians, right? So we need to add them consecutively, right? And so we'll then go ahead and do final equals cum sum on theta. And so now what we see is that the final edge grows. It gets to 6.28, which is 3.14 times 2, which is a whole circle. Cool. So that's going to be the final edge. Now we need to think about the initial edge. So we'll do initial. And for that, I'm going to go ahead and do lag on final. So lag should tell us the difference between each of our final theta values. And so now what we see is that this final becomes the initial for professions, right? And that this, the final for professions, becomes the initial for trade, okay? But we have that NA value in the first slot for initial. We can make that a 0 by doing default equals 0. And so now we see that we have that 0 there, okay? So now we have all of the data we need, I think, to draw our pie chart. So I'm going to draw a wedge for each row in this data frame. To do that, I'm going to nest the final and initial columns into their own data frame, and then we're going to use map from the per package, which is part of the tidyverse, to run our generate wedge function on each row. Don't worry if you've never seen this before, we'll go through it somewhat slow. All right, so let's go ahead in here, and I'm going to start by removing the basic theta column, right? So we only have final and initial, and you know what? I'm going to call this final theta, and then initial theta, and then I need to update this final. All right, so now we have final theta, initial theta. Then what I'm going to do is nest. So I'll create a column called theta that is made up of, we'll do initial theta and final theta. And so now what we see is that theta is a set of tibbles, right? So each row then has a tibble in it, okay? Now what we can do is we can pipe this to mutate, and we will then create a column that I'll call wedge, and that is going to equal map. So the map function allows us to go over each row successively and apply a function to the data in that row, okay? It allows us to basically go row-wise through the data. And so what are we going to map over? Well, the theta column, right? And we're going to apply to that the generate wedge function. And this theta is actually in the .x slot, right? And so generate wedge will then need the theta I and the theta f. So we'll do $x $ initial theta and $x $ final theta. And let's go ahead and put this on a new line. So now we see wedge is a column of tibbles, much like theta was, right? But this all gets a bit compressed, so we can't totally see what's going on. Let's go ahead and remove the theta column. So we'll go ahead and do select minus theta. And so we see it's got 102 rows and 2 columns. So what are those 102 rows? Well, remember we've got 0, and then we have 100 values as the resolution for the edge of the arc, and then back to 0. And then the 2 columns are x and y. So now we can go ahead and do an unnest on our wedge. And I think they want us to put this in a C function. And so now you'll see that we've got our category, our race, the percent, the race category, and the x and y coordinates. Okay? Getting excited? Good, me too. So now we can go ahead and pipe this to ggplot, AES, and then the x is going to be x, y is going to be y. We'll then do group for the race category. And I think we can do fill by category. And now what we can do is geom _ polygon. Very good. We have our pie chart, our first draft of it. Of course, our axes are not the equal size, so we'll want to modify that. But I'm noticing that the blank is starting at 0 rather than at, say, 30 degrees, which would be half of 60 degrees, right? So I could modify this 60 to be 30, but that's going to throw off the entire proportion of all of the wedges. So let's come down further here, and let's kind of interrupt our pipeline here and remind ourselves of what we had here, right? So we want this final theta to actually be half of that value, right? We want it to be, it was like 0.59 or something like that. Instead, what we'll do then is subtract half of that first value in the theta column. And there just happens to be a function called first. So we can do first on theta. So now what we see is that our final theta is 0.589 rather than 1.18, and our initial theta is 0, and that this then goes down to 4.44, which is going to be about 30 degrees short of 2 pi, which was 6.18, right? So let's go ahead and reintegrate this with the rest of the pipeline. And so now what we see is that 30 degrees is missing, right? But this blank category is this kind of ugly mustard color, right? And so I think what we can do is entirely drop out the blank category using a filter, because we have the start and end coordinates of each of our wedges, right? So let's come back up here. And after we've done all of our theta calculations, let's go ahead and do filter category not equal to blank. And we'll pipe that. And so now we have our wedges taken out and we don't have blank showing up as a category. So let's go ahead and make our coordinates equal. So we'll do chord equal, and there we go. We now have what looks more proportionally like what DuBois had in his figure. Now we are ready to start modifying the appearance of this figure to make it look far more like what DuBois had. And again, we are doing this in Cartesian coordinates. So again, x equals r times cosine theta, y equals r times cosine or times sine theta, right? Versus using chord radial, because these next steps will be far easier to do in Cartesian coordinates than in radial coordinates. You're going to have to take my word for it. That just the tooling isn't really there to do the kind of things that we're going to want to do with this figure. All right, let's start by working on our colors. So let's start by cleaning up our code a bit. We've got a variety of things in here. So I have this initial and final. I'm going to move my generate wedge function up here to before I define the tribble. And maybe I'll go ahead and rerun this just to make sure I've got that loaded. And then down here, I had where we were doing some experimenting with that geom polygon to create an individual wedge. Now what I want to turn our attention to is let's go ahead and modify the fill colors of these different categories. So let's go ahead and then do scale, fill, manual, and we'll do breaks, agriculture, and I'll go ahead and type these in and I'll be right back with you in a second. All right, so those are the names of the different categories. And then for our values, we are going to use specialized hex codes that have been worked out by Mr. Anthony Starks, who spent a lot of time building these same types of visuals using a platform that he's been using to draw things in a web-based format. So these are the hex codes that he's been able to work out. I'm going to go ahead and follow his lead. And so for agriculture, we want that crimson color. For manufacturing, we want this blue color. So for professions, it's kind of a brownish color. I'm going to assume that's the tan here. And then for services, it's this yellowish goldish color, and that's this hex code. And then finally, we need the professions. And the professions is a grayish color that I don't really see showing up in his list of colors. And so I'm going to go ahead and use gray 80. Yeah, I think that'll work. Very good. We now have all of our colors in here. We can then go ahead and get rid of this legend because we're going to end up making our own legend as we go. We can get rid of that legend up here in geom polygon by doing show.legend equals false. So I think the next thing we'll do is to go ahead and put in the percent labels using geom text in the different wedges. And so this is going to cause us, I think, to need to break up our pipeline here. And so I think I'm going to do it right here. And I will call this initial set of code, I'll call this basic data. And then this is going to be wedge data. And that's going to take basic data piped through here. And then let's go ahead and remove this pipe and then take wedge data and pipe it into ggplot. So let's run this, make sure we still get the same result. Cool, it's still the same result. Again, what we want to do now is to make a data frame probably based on basic data So we're going to want the percent for a label, right? And then we're going to want the position in the y-axis, kind of the vertical placement, if you will, as well as the theta. And we can then use both of those values to get an x and y coordinate space, right? So we'll take basic data, and let's go ahead and do mutate to get a theta. And I'm going to make that the average of the initial and final. So we'll do initial theta plus final theta divided by 2. And so that gets us this theta column. We're also going to want an radius. And so then this is going to be a vector of values starting here with the professions for blacks and then working all the way around. So what I'm going to do is I'm going to go ahead and take the position of these various labels and guesstimate a radius position. So I'm going to do that and I'll be right back. So again, those are some radius values that we might have to fiddle with as we go forward, but I think that gets us a good start. We can then also make a label, paste, and we'll do percent with a percent sign. And so now, well, it dropped off my label. So let's go ahead and maybe clean this up a bit. Let's go ahead and do select minus race category. And so now we see, our label has a space, whereas the original did not. So I need to go ahead and maybe make that paste 0 to then get that space removed. All right, so now we need an x and a y position, okay? So again, do you remember the formula for x? It's gonna be radius times cosine theta, and then y equals radius times sine theta. And we don't need to worry about using a map here because we're only dealing with each row separately, right? We're only calculating one value for each row. Whereas before, when we were making the wedge up here, for each row, we were generating 102 values, right? And so now what we see is the x and then the y, of course, is being hidden. And so that's fine. Now let's go ahead and call this label data. And we can then incorporate that into our plot. Down here, we'll go ahead and do geom text, and we'll do data equals label data. And then AES for our mapping, x will be x, y will be y, label will be label. And then we'll do inherit.aes equals false. And that is because we don't want to use the fill or the race category here, right? And so let's go ahead and add that. And while we're here, why don't we go ahead and add family? So we'll do Vasserly. Very good. We now have our labels inserted into our plot. And so we now need to work on shrinking the size of those fonts, right? And so we can see like this 62 and 28% are about the same size, but the 5, the 4.5, and the half are much smaller, right? And so we can kind of see similar things across here. And so what I'm going to do is back up here where I had my label data, I'm going to create another column that I'll call size. And then again, I'm going to go through and kind of manually adjust sizes to get sizes that will work. And I'm going to put the sizes in here in the same order as our race categories. Okay, so again, I've put in sizes, and Negro profession is the 5, and Negro agriculture is the 8, right? And so we'll see how these work. Let's go ahead and load label data. And then down here, I'm going to do size equals label data $size. And so I'm doing this outside of the aesthetics because I want to use those actual size values, right? If I put it into aesthetic, then it's going to scale between 5 and 8. And I don't want it to do that. I want to be pretty specific about my sizes. And so then I'm also going to use size.unit equals pt to make sure that my sizes are in point font size. And there we go. We now have our percentages on our pie chart. And I think those look pretty good. We'll of course be doing some fiddling. That 4 might be a little bit too large. And that some of these values might also need to be moved in a little bit. Like this 4 is right on the edge. The 5.5 is on the edge, whereas over here it's pushed in, and the 13.5 pushed further in as well. So we're going to have to adjust some of these things as we go forward. But let's not worry too much about that just yet. The next thing we should do is go ahead and put on our title, as well as the label for the top and bottom fans on this chart. I'm going to go ahead and copy the title, and we'll go ahead then and do labs title equals that. And while I'm here, I'm also going to do x equals null, y equals null. All right, so that got us our title. Let's go ahead and modify the title to be the same font or similar font to their handwriting. That still makes me chuckle. Theme, and we'll do plot.title equals element text. Family is B52, and the size I think should be like 12, and our HJust should be 0.5 to make it centered. So I think that font is a pretty good size. So let's go ahead and remove the expand around our plot. And so we could do that here in chord equal. We could do, we'll do expand equals false. We'll also do clip equals off. So now let's modify the margin for our title. And so again, we can do that up here in plot title. We'll do margin equals margin. T, let's do 15. B, let's do 20. And I think we got the top pretty much right on, right? And I think we might actually be pretty close with the bottom, although that might need some adjusting. It's amazing how playing with these, these settings so much, I'm starting to develop an intuition for how to use them. All right, so now let's add the Negroes and the Whites labels to the plots. And so I'm gonna do that with an annotate rather than a geom text. So we'll do annotate, and we'll do geom equals text. And then our X position is gonna be 0, and our Y position, we're gonna have 2, right? So let's do like 1.05 and then negative 1.05. And then we need a label. So we'll do label is Negroes. And it had a period at the end. Yeah, I had a period there and a period for whites. And so then we'll add that and add a plus here. So that added it to the plotting window. I'm gonna go ahead and add the limits to chord equal here so that I don't have to worry about things moving around in the plotting space, that it'll stay outside of the plotting space, if that makes sense. So let's go ahead and do xlim, c -1 to 1, ylim, c -1 to 1. And so now we see that those labels are outside of the plotting window, which is great. So let's go ahead and add our Vasserly font. So we'll do family equals Vasserly. I think it's perhaps a little bit too big. So let's go ahead and reduce that. So we'll do size equals, let's try 8. We'll do size.unit equals pt. And I think that's about the right size. So funny things have happened with our margin, of course, above the title. I'm going to hold off on adjusting that until I get everything else placed, because we're going to need to move a few things around. I want to go ahead and leave these axis labels on for now, just so I can use it to help position my legend, okay? And so let's go ahead and add the legend. So I'm going to create another data frame that I'll probably call legend data, but let's hold off on that for right now. So we'll create a tribble, and we'll have x dot, and then we'll also have x label, because those are going to have to be created separately, right? And then we'll have y, and then we'll have our category. And so we'll want the same categories that we've been using, so that when we go to color the dot, it'll be the same color, right? And then the label. So the label has been these longer names that I haven't been using so far. The dot, I'm gonna have be right between the edges of the fan. And so if I look at mine, I've got this thin grid line is 0.75, right? And so I'm gonna say maybe like 0.8, negative 0.8 and 0.8. So let's go ahead and do negative 0.8. And then we'll also do 0.8 for the ones on the right. I'm gonna kind of rough some things in here. I'll also do negative 0.75 for the label. And then our Y is going to be a little bit above the axis, right? And so again, this is 0.25. So maybe I will make that like 0.15. So that's gonna be positive 1.5. Whereas the one below it is gonna be negative 1.5. That's gonna be the Y value. And then our category is gonna be agriculture, and then manufacturing. And then for now, I'm just gonna put in some random text for the label, because we'll get that eventually. And then on the right side, we said that the dot would go at 0.8, and the X label is going to be inside of that a bit. So let's make it the same place, right? Like 0.75. We'll, of course, need to fiddle with the horizontal justification. Our Y then is going to go up higher because there's 3, right? I'm thinking maybe we want to put that up to like 0.25. And I think this was supposed to be 0.15, not 1.5, because we don't go that high. All right, 0.15, 0.25. And so that would then be services, I believe. And then let's go ahead and plop in these X's. And then we're going to do 0.8, 0.75. And then this is going to be at 0. And that's going to be professions. All right, and we'll copy this. And then we're going to have 0.8, 0.75, and then we're going to do negative 0.25. Let me bring this back a little bit. And this is going to be trade. And then we're going to put in our X's, okay? And so, again, this is what our Tibble looks like. Let's go ahead and save that to legend data. And so now we need to bring legend data into our ggplot pipeline, right? And so let's start with geom point, and we'll do data equals legend data. And then our AES, our mapping, X is going to be X, Y is going to be Y. Our fill will be category. And then our shape will be 21. And let's do a size of, say, 5. And let's see where that gets us. And it's not happy. Object race category not found. And that is because I forgot to use inherit AES equals false. So I'll go ahead and put that in here. All right, that's what happens when you don't say ignore your inheriting of the AES values. All right, so it's upset with X. Oh, and that's going to be X point, right? X dot, I think I called it. X dot. All right, we'll try that. Great. Now it's happy. And I feel like those points fell pretty close. They could probably go to the left a little bit. I'm going to go ahead and get rid of the legend on that geom point. And so we'll come in here and do show.legend equals false. Good. Yeah, I think those can go out just a smidge. I'm going to try a couple values. Let's try like 8, 5, 4, 3, 2, 1. I feel like this golden one is probably the best. And so that was the third one down. So let's use that value. So that was 0.83. So we'll do 0.83, negative and positive 0.83 for all these. And good. There are our points. And they could probably be a bit bigger. So let's go ahead and up that to, say, 7. And I think that's pretty good. All right, now we want to put in our text label, right? So I've got kind of dummy text in there. So we'll go ahead and rough in the geom text function syntax. And again, we'll do data equals legend text. Before I forget, we'll do inherit AES equals false. We'll do show.legend equals false. And then our mapping on X is going to be X label, I believe I had. And then Y is going to be Y. And then label is going to equals label. And then our HJust is going to be the justification for those 5 labels. There's a few things going on here, but I think the ones on the left need to be left justified, and the ones on the right mainly need to be right justified. So let's go ahead and do 0, 0, 1, 1, and 1. Get some spaces in here. And then we'll also want our font, right? So let's go ahead and do family equals Vasserly. So let's do size of 8, or size.unit equals PT. And let's add that in. And object legend text not found. Oh, it's supposed to be legend data, not legend text. I think I heard someone yell at me. Thank you. And so there is our fake legend text, all right? So I'm going to now replace these X values with the actual spelled out names. I'll be right back. So I've got those filled in. Let's go ahead and run this and see what it looks like. So right off the bat, I noticed the font is too big and the line height is too big. So let's go ahead and shrink that down. And that's easy enough to do. So let's go ahead and make it 6. And then for line height, let's go ahead and make that 0.8. So I've noticed that like on their domestic and personal service, I think they wanted it to be left justified, but because it was running into the line there, they bumped over domestic. I think what I'll do is go ahead and center that to get kind of a similar appearance to what they had. And then we'll have to move over the center, right? And so that, again, was 0.5, 0.75. Maybe it should go at like 0.65. And so, again, we come back up here to our X label. And I think I said 0.65. And let's then modify that HJust to be 0.5 to be centered. And that's too far over. So let's move that back. 0.65 wasn't right. Let's go ahead and make it maybe 0.5. Okay, that's too far too. Let's split the difference and do like 0.58. Maybe it could go over just a smidge more. Let's put it to 0.59. So the nice thing about having this grid line here is that professions is lined up right on it, right? And so then I can make sure that everything is lined up on that as well. So trade and transportation is also center justified. So let's go ahead and maybe put it at the same spot that we had for services. So we'll make that 0.59. And then coming down here, we'll also make that center justified 0.5. And that's good, but it needs to come over to the right a bit. And so let's make that 6.1. And that's bang on good. All right. Now let's turn to the left side of the plot. And here I notice that there's quite a bit of space to the left of the and in agricultural, fisheries, and mining. So let's go ahead and add some spaces to the label. And I don't know how many to add, but a few, and we'll remove that period. So I think that's pretty good. Maybe we could add one more just to be obnoxious. Good. I'm noticing that A falls between the T and the U on mine, as well as on theirs. Great. This is looking good. We're very close. Now I want to turn off the background, the axis text, the axis ticks, and then we'll start fiddling with the margins to get everything to look right, hopefully. All right. So we'll come back in here and we'll do axis.text equals element blank, axis.ticks element blank. So now we also want to remove the grid line. So we'll do panel.grid equals element blank. Great. That's all been cleaned up. Now we want to remove that background. And we'll go ahead and then do plot.background equals element rect. And then we'll do fill equals white to get the white fill, obviously. And I always like to put in color equals white, just in case. I've had plots made where there's like a black border. So I just like to be safe. So that did nothing. I think what I meant to do was panel.background. So I'm worried about this margin at the top. One of the things I have experienced with chord equal is that it brings everything to the center of the plot. I'm wondering if I do like plot.margin equals margin. Let's do B equals, say, 20. That didn't do anything. What happens if we go up to like 50? That brought that up, and that then pushed our title up. So now let's get a bit of space between our title and that label. So again, in plot title, B we had for 20. Let's try 40. Wow, that actually looks right. Maybe the top could come down a smidge, but I'm not going to worry about that. Let's double check the placement of our titles. Maybe a little bit too far. Let's go ahead and bring those in a bit. We did that with annotate here. Let's do 1.03. Now let's look at our percentages. I think these look pretty good. I think the sizes are good. On the bottom, I think that 4% needs to move in, as well as the 13.5. Well, these four values need to move in. So that was done in label data. And so these bottom values, right? So that 4 we want to bring in, it's currently 98. Let's make it 97. 13 is at 95. It needs to come in a bit more. Let's make that 93. This blue is at 97 and it needs to come in. So let's go ahead and make that 95. This 5.5 is at 98 and it could come in a little bit. So let's maybe make that 97. Yeah, I like that. I think this 13 and 13.5 could come in a little bit more. So let's go ahead and just for the practice, we'll go ahead and modify that. And so let's make this 91 and 93. Good. I'm going to call that good. All right. So one final thing that's annoying me is the margin above the title. I have problems, don't I? So that was set up here with 15 and it needs to come down. So let's maybe make that 20. Maybe we can remove some bottom margin from that. So I added 5. Let's make that 35. I think that's pretty good. You know what? One final thing I'm noticing we don't have is a border. It's little things. So here in Geom Polygon, we can do color equals black to get a black edge around each of our wedges, right? So now you see that black edge, but that's way too thick. So let's go ahead and bring that down. I want it to be really faint. So we'll do line width equals 0.2. That might even be too thick. Let's just take that down to say 0.1. I'm good. That's got just a really nice, simple black edge that you can see, especially around the trade and transportation category and kind of these lighter colored wedges. And I think that looks nice. So I'm really happy with the way this turned out. Let me know what you think, please. Again, I had tried doing this with a stacked bar and then converting that with chord radial to make a pie chart. It just didn't work. And believe it or not, I think this is the easiest way. And so to recap, what we did was we drew each of these wedges using a specific function that I think I called generate wedge. And we used some trigonometry, right? So being able to convert a radius and a theta, an angle, to an x and y coordinate allowed us then to show this in Cartesian coordinates. That then made it pretty straightforward to place our numbers, right? Of course, that also required knowing a radius and a theta, as well as to place our legend, right? And so this legend would not have been possible using kind of the built-in legend systems that come with ggplot2. So we had to do some fancy things to make this really cool fan chart. I'm pretty strongly on the record as being anti-pie chart, but I think this is really cool. And I think it's also allowed us to kind of work our ggplot2 muscles, learning about Geom Polygon. I have a feeling we're going to see Geom Polygon make a few more appearances before I'm done looking at these DuBois visualizations. Let me know what you think. If you've played around with Geom Polygon to draw your own wedges, there may be packages out there to do things like this for you. But again, I'm trying to limit myself by using only things that I get when I do library tidyverse. And so that's what I got. And I think this is pretty cool. We did this in 107 lines of code. This is one of the longer sets of code that I've written. But again, I think the product is pretty cool. Let me know what you think of these videos going back through the DuBois panels from that 1900 Paris Exposition. I've got a few more in the works before we move on to other things, but I hope you're enjoying seeing this other way of working with historic plots to learn to use our own modern tools far better. If you wouldn't mind, please give this video a thumbs up, let your friends know what we're doing over here, and help to spread the word. And we'll see you next time for another episode of Code Club.